Today you will learn about qualitative graphs. You should be on page 48 in your notes packet. Qualitative variables are verbal descriptions of what is happening in graphs. Typically, we work with quantitative variables, which give us numerical descriptions. But with qualitative, we don't know typically exact times or measurements, but we can use a basic description to draw a graph. Some examples of qualitative variables that you can use to describe a graph is whether it is linear or nonlinear. So, does it make a line or does it not make a line? You can also use slope because even if you don't know the exact slope, you can describe a slope as being positive, negative, zero, or undefined. You can also talk about whether or not there is a constant rate of change occurring in your graph. Another thing that you can describe in a qualitatively is showing where your graph increases and where your graph decreases. Let's look at an example. This says Melanie left her house and drove to the mall, where she shopped for 1 hour. Then she drove to the movie theater where she watched a movie for 2.5 hours. From there, she drove back to the mall to return a sweater she decided she didn't like, which took her about 30 minutes. She went back home after leaving the mall. If I wanted to draw a qualitative graph of this, I can draw a graph that shows about what happened, although I don't know specific distances. I know that I can represent time on my x-axis because time would always be my x-axis or my x value. And then on my y-axis, I can describe this as being Melanie's distance from home. In this situation, it said Melanie left her house and drove to the mall. Well, that means that Melanie started at her house. So when this started, she had zero time and she was also 0 feet or miles away from her house. So she was right here at the origin to begin with. But we know that she drove to the mall. And we know it took probably a little bit of time to drive to the mall. So we're going to have a graph that increases on the distance part and also on the time part. Now, once she gets to the mall, she shops for 1 hour. So at this point, she is going to remain at the mall. So she is the same distance from home, which means that we are going to draw a straight line to show that she shops for 1 hour. So the distance doesn't change, but time does go on. From the mall, she drives to the movie theater. So we're going to show that she drives further away. And then she stops at the movie theater and she watches a movie for 2.5 hours. Well, you notice that this part represented 1 hour. So if she's watching the movie for 2.5 hours, then that's going to be a longer line. So again, the distance is not changing because she's sitting at a movie theater, but the time is going by. After the movie, she drives back to the mall. Well, we know that she was at the mall during this time, so I'm going to show that she goes back to this approximate location. Now, from at the mall, she returns a sweater that she doesn't like, and it takes her about 30 minutes. So that should be about half the time that she was there the first time since she was there for an hour. So I'm going to draw a smaller line than that first line. And then after she leaves, she goes home after she leaves the mall. So from here, she drives back home. And again, she's not going to get home immediately. So she's going to drive home, which is going to change some time and the distance. Next, we see Susie rode her bicycle at a constant speed for 5 minutes. So if we're looking at this, she's riding her bicycle. So this one is also probably going to be time and then distance from home. So if she rides at a constant speed, that shows that she is accelerating at a constant speed. So that should be represented using a straight line. Now she does that for 5 minutes. So time elapses for about 5 minutes. Then she stops at the store to buy marshmallows. Now we don't know how long that takes, but we know that the distance is going to stay the same while time changes. After she gets her marshmallows, she rides back home again at a constant speed, but this time it takes her 10 minutes. Well, if we compare that to before, it seems like it took her a short time to get there the first time because it only took 5 minutes. But the second time, it's taking 10 minutes. So the distance is going to get closer to home, but the time is going to take longer than the first time. Next, we see John left home to go fishing. So again, we have somebody who is spending time and traveling a distance. When he got to the lake, he realized he had forgotten his fishing pole. So at first, John leaves home to go fishing. So we don't know where he went, but he goes all the way to the lake and goes fishing. But when he gets there, he realizes he can't go fishing because he doesn't have his fishing pole. So he has to turn all the way around and go back home. So he goes back home, and at this point, he's home. He gets his fishing pole, turns right around, goes back to the lake. So we get back to the lake. But then when he got back to the lake, he realized he had forgotten to pick up any bait. So he turns around to go back to the store that he passed on his way. Since he passed the store on his way to the lake, that shows us that he went by the store, so he would have already passed it. So it was somewhere here in between home and the store. Now, when he gets there, he spends about 30 minutes picking out bait. So we're going to show that he spends some time picking out bait. Then he turns around and goes back fishing. And once he finally has his bait and his fishing pole, he stays for 5 hours. So to show that he stays for 5 hours, I'm going to show a longer line. Then it says he returns home. So from here, he packs up and he goes back home. Now I want you to write a situation that might represent this graph.